With today's lecture. So today we'll be dealing with another concept in the biomechanics, very important concept, and it is the law. In addition to this law, we'll also talk about impact biomechanics, and thirdly, we'll touch work and power. So all these three are very important in biomechanics with regard to sports also, and as such in real life also. So the students who are coming, please write your name in the chat box so that we can mark you as present. Okay, so starting with the today's lecture, Newton's law of universal gravitation. Okay, now gravity, you all know what is it. It is a force of attraction, right? So this is the first slide in which you can see an apple and our earth. So in simplest terms, if I say what is gravitation force, on which object or subject it acts, the first condition for that is non-zero mass. Means if you want to have force of gravitation between the two objects, then those two objects should have non-zero mass, or they should have some mass. If they have no mass, then no force of gravitation can act. Now in this case, you can see in your front of you that there is an apple and an earth. So these are the two objects. And what is force? So what is this law? This law tells us about what is the force between these two. So universally, according to this law, there is a force of gravitation between any two objects who have mass. So in the present slide, we have apple and an earth. Both are two bodies, and both of these bodies have some force between them, which is known as gravitation force. This is force of attraction basically. And how we can find it, this law tells us. Okay, so this is the first example slide to show you that it exists between the two objects. Now second point, it exists between us also. Us means you and me, any two individuals standing or sitting. So any object on this planet who has mass, so between the two objects there is a gravitational force of attraction. So that force is governed by this law. Okay, so the Dinesh has also arrived. Okay, thank you. So how we can define it? So basically, coming to a setting slide, then you will get idea that both of these objects will attract. Both of these objects will exert a force towards each other. Apple will also exert an attractive force. On the other hand, Earth will also exert an attractive force. Now the question comes, which object will accelerate? Means you have seen the example when you apple tree pe hai niche gira. So what falls? Apple. In other words, if you see it visually, you can see the smaller object accelerates. But there is also a physical principle behind this. That is Newton's law of acceleration. Newton's law of acceleration says F equal to ma. From that we can get acceleration, right? So acceleration is inversely proportional to mass. So out of these two, Apple and Earth, Apple has less mass, Earth is huge. So Apple has less mass, that means it has more acceleration. So both of these bodies are attracting with the force of attraction. We call it as gravitational force, but Apple will fall. Apple will accelerate. Why? Because Apple has less mass. That is the thing you should keep in mind. When two objects are there, the one which has less mass, that will accelerate. However, there will be force of attraction from both the sides, right? This is the point, should be clear. Now coming to the law. In the next slide, again I have shown you the same thing which I have told you. See, here I have shown you the second law also. After this I will proceed to next main law. So basically, in this slide I have again shown you that the mass is the dependent factor on which acceleration depends, and these are inversely proportional. So lesser the mass, more the acceleration. Okay, so this slide is a graphical representation of which I have told you in the previous slide, that if the object is small, then it will accelerate, and if the object is heavier in mass, then it won't. Okay, so this is the concept. Now coming to some key points before moving to the main law. So here's the slide. So what are the key points to remember? All objects attract each other with the force of gravitation, that I've told you, right? Now this force will depend upon two things. First one is masses. What are the masses of two objects? And second thing is distance. However, the relation is different. It is directly proportional to the masses, means higher the mass, more will the force of gravitation. And with respect to distance, it is inversely proportional, means lesser the distance, more will the force of attraction. I'll repeat, this force of gravitation according to this law depends upon two things. First thing is masses. Larger the higher the heavier the mass between of the objects, more will be the force of gravitation. Second point, distance. Lesser the distance, more will the force. On the other hand, more the distance, less will be the force. If I talk in Hindi, जो भारी ऑब्जेक्ट्स हैं, अगर वो भारी हैं तो फोर्स ज़्यादा होगी, ये डायरेक्ट डिपेंडेंस है. इन्वर्सली डिपेंडेंस क्या है कि डिस्टेंस क्या है उनमें. इफ़ टू ऑब्जेक्ट्स हैव लेस डिस्टेंस, कम डिस्टेंस पे हैं, उनमें फोर्स ऑफ अट्रैक्शन ज़्यादा होगी. ऑन द अदर हैंड अगर उनमें डिस्टेंस बढ़ जाता है, देन फोर्स ऑफ अट्रैक्शन कम हो जाएगी. सो दिस इज इन सिंपल टर्म्स यूनिवर्सल लॉ ऑफ ग्रेविटेशन. नाउ इट इज़ यूनिवर्सल. ये थर्ड पॉइंट आपको दिमाग में रखना है, दैट दिस लॉ इज यूनिवर्सल. इट इज़ एप्लीकेबल एवरीवेयर, not on the earth and on each and every planet. The first condition is that there should be a uniform gravitation. So third point you always keep in mind, it that is universal. That's why we call it universal law of gravitation. And fourth again point says that more massive objects will attract each other with a greater gravitational force, that I have told you. अगर मास ज़्यादा होगा, the force of attraction will be more. On the other hand, if the mass is less, then it will be less. If you talk about distance, distance में उल्टा होता है. If distance is less, then force will be more. On the other hand, if distance is more, force will be less. Now coming to the mathematical equation on the next slide. So here the mathematical representation of universal law of gravitation, that force of gravitation is directly proportional to masses of both the bodies. Mass of first object, mass of second object, we will multiply them and divided by d square. That means the distance between them will be squared. So this is the mathematical equation. m1, m2 are the masses of the objects which are being considered, and d is the distance between the two objects. Okay, and that sign is of proportionality. That means they are dependent upon that. So if we want to omit this proportionality sign, we'll have to put gravitational constant. That will come next. So what is that? Okay, so this is the mathematical equation for Newton's law of gravitation. So in the next slide, you will get to know how these varies. So force dependent on masses and distances. So in this slide, graphically I have shown you so that you can understand how this gravitational force varies. First of all, look at the left side where I have shown the dependence upon mass. See, in the first case, so these are the two objects m, m. You can see the two blue balls. These are the objects which are being considered, and d is the distance between them, and F will be the force which is dependent upon directly on the masses and the distance. Now I'm talking about mass only in this section on the left side. So if we increase the mass of right side ball, we'll make it twice, 2m. Then what will be the effect on the force? As it is directly proportional, the force become 2 times. Similarly, if I, in the next, you can see I have made both the masses double, 2m 2m, then the force will become 4 times. So this is to just demonstrate how mass affects the force. जैसे ही mass increase हो रहा है उसी factor से you can see force is increasing, right? Now coming to the right side, there I have shown you how distance varies the force. On the right side, come to right side now. On the right side you can see first case is normal, that there are two masses and d is the distance. Now if we make the distance 1 by 4, see the second right side second figure, sorry, right side second figure, we have doubled the distance 2d, हमने डबल कर दिया डिस्टेंस. सो व्हेन यू डबल इट द फोर्स विल बिकम 1 by 4th ऑफ इनिशियल. वाई? यहाँ क्योंकि यहाँ पे स्क्वायर वाला इफेक्ट आ रहा है, डी स्क्वायर हो रहा है. अगर हम डबल कर रहे हैं तो 4 टाइम्स इफेक्ट डाल रहा है, 4 टाइम्स फोर्स कम हो जाएगी. इफ यू डबल द डिस्टेंस बिटवीन द टू ऑब्जेक्ट्स द ग्रेविटेशनल फोर्स बिकम 1/4 ऑफ इनिशियल. So that's why 1 by 4 F. So in the third figure हमने उस डिस्टेंस को आधा कर दिया, 1 by 2 कर दिया, मीन्स डिस्टेंस क्लोज कर दिए. So when you do this, then again effect will be 4 times. So force became 4F, 4 times बन गई. So this is the case in which you can see how masses and distances affect force of gravitation. Mass का direct proportion है, direct effect है, and distance has inverse effect. But in distance we have square factor, मतलब वो double effect आएगा. I think point is clear how force depends upon mass and distance according to this law. Now coming to the second next slide, which will give you the official definition of this law. So scientific definition of the law is all bodies are attracted to one another with the force proportional to the products of their masses and inversely proportional to square of distance between them. So this we have already discussed. So this is the equation. Now the new term here is capital G. So what is that? Capital G is the constant. Now you will must be thinking how it has come. So in the next slide you will know how it came, how it get calculated basically. So this always remains same in the problem, capital G. So in the next slide I'll let you know how it was calculated and what is its value, constant value. M1 M2 are the masses and D is the distance between them. Okay, coming to the next slide where you can see how G constant value came. So this was an experiment done by Mr. Henry Cavendish in 1798. So this is the apparatus he used and formula was same. You can see just he has a rearranged constant G. So what he knew the distance between the masses. You can see a dark red mass and a gray mass. So this apparatus is known as torsion balance. So using this scientific apparatus he was able to calculate F is what? Force of gravitation. R he knew what is the distance between these two. M, capital M is the mass for gray ball, small m is the mass for the smaller ball. So using this apparatus, controlled apparatus, he was able to calculate G, capital G, and its value is given below. It is 6.673 into 10 to the power minus 11 Newton meter square per kg square. So this is the value you should always remember. This is the constant value in each and every problem. If you're dealing with gravity, you have to use this constant. And one point I want to make you very clear here, that you can see it is 10 raised to the power minus 11. That means it is very small. 10 raised to minus 11 अगर आपको मैथ्स पता होगा कि ये जब नीचे आएगा 0.00000, you can see very small magnitude it has. So what is the point of telling you here? The point of telling you here is this, कि आपके मन में दिमाग में आ रहा होगा कि yes we can see force of gravitation by earth because earth is huge. अब मैं कह रहा हूँ this law is applicable to every two objects which has mass. हमारे बीच में भी है, two boys are standing, they have also force of attraction but they don't feel it. Why? This is the reason, because it is of very small magnitude. जब आप दो 70 kgs के इंडिविजुअल्स में कैलकुलेट करेंगे, you will see M1 M2 become 70 kg or 65 kgs. You can see the G constant, it is very small, 6.673 10 to minus 11. So the point idea is, between individuals it is very small because mass is very small as compared to earth. अर्थ का बहुत ज़्यादा ह्यूज मास है, इस दिस इज द रीजन वी फील इट, वी फील द फोर्स ऑफ ग्रेविटेशन ऑफ अर्थ, बट वी डोंट फील ऑफ आर्स. वाई? बिकॉज ऑफ दिस, द ग्रेविटेशन कॉन्स्टेंट इज वेरी स्मॉल, our masses are very small as compared to earth. So this is the reason, but it exists, there is a force of attraction between every individual, two individuals who have mass. I hope the point is clear. Okay? Now, what are the applications? So before moving to the real applications, I will let you know to focus on this problem. So in this problem, you can see using this formula we can solve it. So the problem says find the force of gravitational attraction between the earth and a 70 kg athlete if he is standing at a sea level a distance of 6.38 into 10 to the 6 meter from earth's center. So if you focus on this problem, you can see you have got every value, just you have to put that formula, law of gravitation. You have put the value, you have to put the value, you have to put value of constant G that you already know. And what you know, what you need, M1 M2. M1 is mass of athlete, that is 70 kg. What is M2? Mass of earth, that they have given 5.98 into 10 to the power 24 kgs, right? Distance they have also given 6.38 into 10 to the power 6. So everything is there, just you have to put the values and you will get the answer. So this is the thing, this is the way you can get it. So this is the answer, 686 Newton. 686 Newton is the answer. For using this formula you get to know, so what is the force of attraction between that athlete and earth. So in this way you can apply this law and this equation to calculate force of gravity, right? Now in the next slide there are some problems I have given you. You try at your home and try to calculate using this equation these problems, and then you can comment the answer here chat in the chat box also, and on our WhatsApp group also, and then I'll share the exact answers. So after this class you can try these at home. Okay, so this is kind of your homework. You can try these two problems. I've given you the data, you have to apply that law and you will get the answers. So try it, you will get to understand how it works. Okay, now in the next slide I'll let you know what are the application of this law in games. So in games, you see gravity is there everywhere. You are running, you are walking, okay. But if you talk of technique, then throw games are there. Throw games are, you can see there are 4 prominent throw games we have: shot put, discus, javelin, and hammer throw. So these are the 4 main games, throw games, where you can utilize this law. How it is utilized, I'll let you know. So in all these games, you will see you are throwing something, you are throwing a ball. So in other words, you are launching a projectile, and the ultimate aim in all these games is to throw as far as possible. In other words, technical biomechanical words, you want to increase your range. कितना दूर जाएगा थ्रो आपका डिस्कस, आपका जेवलिन, that is the main aim of an athlete, and this law of gravitation will apply here. How? When you think of projectile motion, because when you throw an object in the air, so that is basically a projectile motion, and that projectile motion will somehow connect with this law. So in the next slide I'll let you know. Coming to the next slide, how throws are affected. So when you throw any object, what are the factors on which it depends? The first one is the angle. Angle of throw is very crucial. Why? We are now talking about projectile motion. You all know what is that. In projectile motion there are multiple factors, but here we will talk about only angle, because this is the one which is related to gravitational law. What is the angle? Angle क्या है? जब आप किसी angle पे throw करते हैं, angle can alter the range. As you know, if you throw any object at 45 degrees, it will have maximum range according to the projectile motion laws. If there is no windy situation, climate is okay. ठीक है, ये इसकी एक कंडीशन है प्रोजेक्टाइल मोशन की. इफ देयर इज विंडी सिचुएशन, देन दैट एयर ड्रैग विल कम इनटू प्ले, देन दिस डजंट अप्लाई. So I am talking about very fine climate. In fine climate, when you launch a projectile at 45 degree, you will get maximum range, right? On the other hand, if you decrease the angle, okay, if you decrease the angle and launch the projectile below 45 degrees, then what will happen? You will lose range. आपकी range decrease हो जाएगी. Why? That is the answer which we can get from law of gravitation. So in this slide you can see I've shown you throws are affected by angle. Biomechanically it is a projectile motion. So when you talk of projectile motion, 45 degrees is an ideal angle, so that you can get maximum range. So if below 45 degree you launch it, you will lose range. The range will decrease. Why? This is due to law of gravitation. This I'll explain in the next slide. Now going to the next slide, so you get to know what is the relation between the two. So when you launch a projectile below 45 degree, gravity will come into play. Now the projectile and the earth will be closer. If you decrease the angle, see here that the distance work is going on. Distance factor is coming. So when you launch the projectile at lower angle, then the distance between the earth and the projectile, कुछ भी आपका javelin है, discus है, whatever you are throwing, that will come more closer to the earth. So when it comes more closer, what will happen? Force of gravitation will increase, and that is the reason it will come faster. It will have less range, because ये जल्दी strike करेगा आपके earth को. So in this way it has affected your range. So in this way this law comes into play and affects your throws. So you have to act accordingly. So this is the main application wise. If you say what is the application? In projectile it works, it affects your throws and it affects your games. So where there is a low role of gravitational law comes into play. So this is it, the sports wise example of this, and this is the key concept for today. Now I am going towards impact. What is impact, and what is elasticity, and what is the application in sports? Okay, so what do you understand by impact? Impact होता है basically collosion. Collosion के बाद क्या हुआ? When two balls collide, when two cars collide, that is known as impact. उसका impact क्या हुआ? उसके बाद उनका क्या हुआ? What is the after result of collision? So that we'll dealing with this impact. What is that? So coming to definition wise, first of all I explain you and then let you know what are the application in sports. Okay, so by definition, impact involves the collision of the two bodies, and when they collide, what they do, they exchange forces. Because जो collision होता है, we have seen, थोड़ी देर के लिए टक्कर बजती है, for very small short span of time they interact and then they separate again, and in that instant of time they exchange forces. So an impact involves collision of two bodies over an extremely small time interval between which two bodies exert relatively large forces on each other. When they are coming with some velocity, both have forces. When they collide, they also give impact on each other. So collision that occurs between, ये एक एग्जांपल आपको बताया. व्हाट इज एग्जांपल? जैसे आप बैट एंड बॉल इन द क्रिकेट, यू नो. सो इन क्रिकेट व्हेन बॉल स्ट्राइक्स अ बैट, सो दैट इज आल्सो ए collision एंड देयर विल बी सम इम्पैक्ट, राइट. अब कौन सा इम्पैक्ट होता है? देयर आर टू काइंड्स ऑफ इम्पैक्ट, इलास्टिक एंड प्लास्टिक. नाउ प्लास्टिक इज अ न्यू टर्म, अदरवाइज इट इज आल्सो नोन एज inelastic. Okay, so latest terms are plastic. So impact का nature क्या हो सकता है? Either it should be elastic or it should be plastic. So key concept here is exchange of large forces in that very short span of time, and as a result of these impact, as a result of exchange of these forces, their result will come how those colloided objects will behave. That will determine the nature of impact. Okay, this will be more clear when I'll show you graphics. Okay, so the behavior of two bodies post collision depends on nature of impact. किस तरह का वो impact है? I have already told you there are two kinds of impacts. One is plastic and one is elastic and plastic. Plastic को inelastic भी कहते हैं. Okay. Now this graphic will let you know very easily. You will understand what is elastic and what is inelastic. Again I am saying inelastic is equivalent to plastic. ठीक है, इसमें confuse मत होइएगा. Elastic is one thing, inelastic or plastic are same, right? So I will now use term plastic only. So what is the difference between elastic collision and plastic collision? Elastic collision क्या होता है? For example, when in this example you can see the ball strikes floor. तो जहां पर ये strike करी, so there you can see the collision happened, and after that collision उसने टपका, it jumped, and you can see the amount of jump is almost same. So that means the velocity with which it was coming, almost same velocity पे ही वो दोबारा after collision निकली. The key point here is the velocity remained same. So in elastic collision the velocities are conserved. Okay, when velocity is conserved, that collision is known as elastic collision. On the other hand, instead of ball, if you throw a clay ball, clay की ball बना के if you throw on the floor, what will happen? क्ले की बॉल डिफॉर्म हो जाएगी एंड इट विल स्टे देयर, स्टॉप हो जाएगी, वो आगे टप्पा नहीं खाएगी, इट वोंट मूव. सो दिस काइंड ऑफ collision इज नोन एज inelastic और प्लास्टिक, बिकॉज इसमें velocities आपकी कंजर्व नहीं हुई. सो दिस इज द की डिफरेंस. इन इलास्टिक collision velocities are conserved एंड इन प्लास्टिक velocities are not conserved. मतलब स्टॉप ही हो जाता है मोशन. सो दिस इज द मेन डिफरेंस बिटवीन इलास्टिक collision एंड प्लास्टिक collision. Now I'll let you know what is the key difference between the two in definition wise. So elastic impact is impact during which the velocity of the system is conserved. Velocity conserve होती है elastic में. In simple words, relative velocity of both objects remains same. This is the theoretical definition of elastic impact. एग्जाम्पल मैंने आपको बता दी है. सुपर बॉल को जब आप थ्रो करेंगे हार्ड सरफेस पे, इट विल बाउंस ऑफ एंड इसकी जो वेलोसिटी ऑलवेज कंजर्व होगी. सेकेंड एग्जाम्पल इज सेकेंड टाइप ऑफ इम्पैक्ट इज प्लास्टिक इम्पैक्ट इन विच द टोटल लॉस ऑफ सिस्टम वेलोसिटी, मतलब मोशन स्टॉप ही हो जाता है, वेलोसिटी जीरो हो जाती है. सो एग्जाम्पल मैंने आपको बताया, क्ले की बॉल फेंकेंगे दैट इट विल स्टॉप. सो दिस इज द मेन डिफरेंस बिटवीन द टू. नाउ कमिंग टू द रियल वर्ल्ड. रियल वर्ल्ड में क्या होता है? रियल वर्ल्ड में इट इज नॉट ऑलवेज 100%. So these collisions are not always means it is not 100% means कुछ velocity का loss होता है. दो बिलियर्ड्स की बॉल जब टकराई उसके बाद collision हुआ और फिर जब वो वापस आई तो little bit of loss, heat loss, thermal loss होता है, but 80 to 90% they have velocity. So रियल वर्ल्ड में 100% नहीं होता. थ्रेटिकली वी कॉल इट 100% की वेलोसिटी कंजर्व हुई, बट इन रियल वर्ल्ड कुछ लॉस होता है 5-10% का. ठीक है. सो ये कंफ्यूजन मिटाने के लिए वी हैव दिस कोएफिशिएंट ऑफ रेस्टिट्यूशन. विद हेल्प ऑफ दिस कोएफिशिएंट वी कैन टेल दैट द collision is elastic or plastic. कैसे? This coefficient has two values, either it is near 0 or it near 1. Whenever it is closer to 1, that means your collision or impact is elastic. उसमें आपकी velocity काफ़ी percentage तक conserve हुई है. On the other hand, if it is less, it is near 0, that means you are closer to plastic. So this coefficient helps you to determine कि collision में elastic collision हुआ है या plastic. Again I repeat, if it is closer to 1, that means elastic collision is there. On the other hand, if it is closer to 0, that means plastic collision is there. So this coefficient will help you to decide, depending on its value, ki whether the collision is elastic or inelastic or plastic, right? So in next, I'll give you the technical definition of this coefficient of restitution. So why is it is there? Because in real world, elastic और inelastic collision 100% pure नहीं होते हैं. Some loss velocity का हो जाता है. Okay. So the coefficient of restitution governs the relationship between the relative velocities of two bodies before and after an impact. So basically ये आपको एक relationship provide करवाता है जिसकी help से you can calculate its value. So how it basically relates initial velocities of two objects before collision and after collision. इन दोनों की relative velocities क्या थी? जैसे दो balls हैं, एक की velocity v1 u1 u2 before collision, then after collision v1 v2 final velocity. तो इन दोनों को जब ये relate कर देता है, ये relation कौन देता है? This constitution of restitution. Okay. So Newton's definition क्या है? When two bodies undergoes a direct collision, the difference in their velocities immediately after impact is proportional to the differences in their velocities immediately before impact. In simple words, जो velocities होंगी दो objects जो collide कर रहे हैं, final velocity will depend upon initial velocity. और इन दोनों का जो relation है, that will give you coefficient of restitution. And this coefficient की application क्या है? It will let you know whether the collision is elastic or it is plastic. How? By calculating the value. If it is closer to 1, then the collision is elastic. If it is closer to 0, then that means the collision is plastic. I think it is clear now. Now I'll come to the mathematical equation of this impact. So in the next slide, this is the graphic to help you understand. These are the two balls you can see. They are colliding with each other. So initial their velocities were u1 and u2, and after collision they separated. Their velocities were v1 and v2. तो इन दोनों के बीच में जो relation है वो क्या है? u1 u2 and v1 v2. So final velocities will depend upon initial velocities, and this relation will give you coefficient of restitution. And below you can see v1 minus v2 is equal to minus e is the symbol. कई books में अकेला e भी होता है, so you don't confuse it. It is not minus, it is just a symbol. This e is the symbol, is known as coefficient of restitution, and it gives you a relation between the final velocities and initial velocities. What it says कि जो final velocities हैं दोनों balls की will depend upon initial velocities, the difference between the two. Okay. The difference of final velocities will depend upon difference of initial velocities. Final velocities क्या है? After collision, और initial velocities क्या है? Before collision. So this will give you coefficient of restitution. E is the coefficient of restitution. Next slide will make you more clear what is it. Coefficient of restitution. So mathematically the relationship can be expressed like this. So minus e is the minus e you can call it e also. It is known as coefficient of restitution. So it is what? Relative velocity of after impact divided by relative velocity before impact. So what are relative velocity? Difference between these two. Difference between the final velocities v1 minus v2 divided by initial velocity before impact u1 minus u2. So this is the way they are related. अब जब आपको इसकी वैल्यू पता लग जाएगी e की, if it is closer to 1, then the impact is elastic, and if it is closer to 0, then the impact is plastic. I hope it is clear now. Now coming to applications of this phenomenon in sports. Sports में how it affects. So it has application in the sport because we have impacts in the ball games, right? जैसे cricket है, tennis है, you know, in these games we have impacts, and depending upon this coefficient of restitution your game can vary a lot, significantly variation आती है. How? I let you know. See, in the tennis, the nature of the game depends on the type of impacts between the ball and the racket. Second, ball and the court. So, nature of game will change if this coefficient of restitution is varied. How? Second point देखिए. If you have tighter grip on the racket, tightening of grip on the racket increases coefficient of restitution. That means it is closer to 1. जब आप टाइट कर देंगे ग्रिप को तो रैकेट की, तो उसका कोफिशिएंट ऑफ रिस्ट्रिक्शन बढ़ जाएगा. सो दैट विल हेल्प यू टू हैव इलास्टिक कोलिजन. और उसका एडवांटेज क्या होगा? वेलोसिटी विल बी कंजर्व. द बॉल जो टाइट ग्रिप वाले जिसका कोफिशिएंट ऑफ रिस्ट्रिक्शन ज़्यादा है, उस पर जब स्ट्राइक करेगी रैकेट से, इट विल मूव विद ग्रेटर वेलोसिटी एज कम्पेयर टू अदर रैकेट जहाँ पर ग्रिप टाइट नहीं है, वेयर देर इज less coefficient of restitution, because वहाँ पर इतनी velocity conserve नहीं होगी. So that is the advantage. So if you have tighter grip, you can increase the range of the ball. You can conserve the velocity of the ball which strikes to the racket. Similarly, baseball में, cricket ball में, you have seen bat का अगर आप nature थोड़ा change कर दें, heavier bat or lower bat और तो ये जो आप alterations करते हैं rackets में या bats में, so that will leads to difference, and that will create variation in coefficient of restitution. And if you make it more towards 1, then you will have more elastic collision and you can conserve velocity of the coming ball. ठीक है. On the other hand, अगर आप बॉल पंचर हो जाए आपकी, सपोज टेनिस बॉल से खेल रहे हैं, उसको आप पंचर कर दो, so what will happen? If you puncture the ball, that puncturing of the ball will decrease the coefficient of restitution ऑफ बॉल. तो वो क्या होगा, उसकी अब इलास्टिसिटी खत्म हो जाएगी. नाउ इफ यू स्मैश इट वोंट मूव एट ऑल. वेलोसिटी में बहुत फर्क पड़ेगा. सो दैट विल अफेक्ट योर गेम. सो दिस इज द आइडिया दैट इलास्टिक impacts are very crucial on the games. It can significantly change your game if you work on that. I think the point is clear. So एक एग्जांपल मैंने आपको नेक्स्ट स्लाइड में, आई एम गिविंग वन एग्जांपल of baseball bats. If you use aluminum baseball bats, they have higher batted ball speeds. Why? Because while using aluminum baseball bats instead of wood, they have high coefficient of restitution in aluminum. So that will help you to increase your ball speeds. So this is the way you can alter your game. You can get significance biomechanically by altering coefficient of restitution in your equipment. So this is the way it helps, it works. I hope it is clear. Now coming to the third section of today's lecture, that is also very crucial, and this is the last section. In this section I'll touch work and power, and these are directly related to any sports. So what is work and what is power biomechanically? Okay, so when you talk of work, first of all we'll focus on the work. You do workout in that gym. So what is work biomechanically? Biomechanically, work means that you apply a force. That is point 1, right? But second point is very crucial, that force should do some motion. For example, you are pushing something, pushing a ball, pushing a table, right? You are applying force. Then when you push it, that table will move. So what happened? Displacement or distance occurred, right? So when you apply force and you have some movement or some motion, then biomechanically you have done a work. This is the technical statement how work is done. If you apply force and you make some motion out of that, then you have done your work. On the other hand, if you apply force and there is no motion at all, motion is zero, table nahi hil raha, you are applying force, then biomechanically the work done is zero. So this should be very clear. how work is done. So in the next slide it will become more clear. The same thing I'll let you know in this one. So what is work? Biomechanically, work is when you apply force to an object. That force produces some motion of that project of that, and then mechanical work has been done. Okay? If no motion happened upon application of force, no mechanical work done. No mechanical work has been done. It should be very clear. मोशन होना चाहिए, मूवमेंट होना चाहिए आपके फोर्स के एप्लीकेशन के पास. मैथमेटिकली this will make you more clear that work done is equal to force which you apply into the distance which it does. कोई टेबल आपने हिलाया तो आपने फोर्स लगाई 20 न्यूटन की, 5 मीटर आपका टेबल हिला, देन यू हैव डन वर्क. कितना वर्क किया आपने? 20 की अगर आपने फोर्स लगाई 20 न्यूटन्स की एंड डिस्टेंस 5, देन 5 इन 20 इन सॉरी 20 की अगर फोर्स लगाई एंड 5 डिस्टेंस है इन मीटर्स, so 20 into 5, 100 joules work done. So this is the way biomechanical work is quantified. Now आपके एग्जाम्पल बॉडी का कैसे दे सकते हैं इसमें, हाउ इन ह्यूमंस इट वर्क्स. So unit I have already told you the unit of work is joule. If you define the unit, how it is defined, work done is said to be 1 joule if you apply 1 Newton force and that 1 Newton force will make a motion of 1 meter. Clear? ये एक definition है आपके how to define units biomechanically. So I repeat, work done is said to be 1 joule when force of 1 Newton will make movement of 1 meter. Okay. Now I let you know the example of human body, how work is done in the human body. This will let you know. So simply when you walk, what happens? When you are walking or running or doing or jogging, your muscles are firing. ठीक है, सभी muscles quadriceps सब fire कर रहे हैं, they are producing force and that force is moving what? Bones. Bones में rotation हो रहा है, some displacement is there, so that's why you have done your work. So this is the way it works in the biomechanics. I think it is clear. Work is equal to force into distance. Force is in the newtons and distance in the meters. Next slide will make you more, it will make you more clear about how biomechanics of work is there, right? So this is the way in our body we do the work. So जो भी आपने movement करनी है, first of all you will fire your muscle. Muscle first of all create tension. Muscle will become stiffer. So that tension will then transmit it to tendon. What is tendon? Tendon will connect your muscle to bone. ठीक है, आपने लात हिलानी है, you are firing your quad. So that muscle will again tibia fibia को affect करेगा. It will transfer that tension to bones and then it will be moved. So first step is muscle create tension. This tension is transmitted to tendons. Tendons attach them bone से. Then the transmission of tension through the tendons pulls the bone and bone move through space and you get the distance or displacement. So force apply किसने की? Muscles ने, and you were able to walk or whatever movement you want to do, you did it with the help of your bones movement, and at the end you got some movement and you have done your work. So this is the way we do work. Okay. Now in biomechanics there are two kinds of works, positive work and negative work. So that you will see in the next slide. Yeah, here it is. So what is positive work and what is negative work? When force acts in the direction of motion, then the work done is positive. मतलब आपने जिस डायरेक्शन में फोर्स लगाई, मूवमेंट भी उसके डायरेक्शन में अगर होती है, if you have the same direction of motion on which you have applied the force, then that work is known as positive work. Examples are kicking a football. When you kick a football, you apply force with your leg and then ball moves forward in the direction where you apply force. Simple. So that is positive work. Throwing a ball is a second example. Pushing a wheelchair in the real life. When you push the wheelchair, you're applying force, and the wheelchair is going in the same direction in which you are applying the force. So all these works are positive works. On the other hand, what is negative work? Negative work is that in which you have applied a force in one direction, but the movement happened in almost opposite 180-degree angle, almost opposite hua. So that work is known as negative work. So now you are thinking about what is the example of negative work. So I let you know by a graphic. You will understand in the next slide. So negative work is, here's an example of negative work. In fact, this guy can tell you both the works, how positive and negative, how. So he is lifting a weight, a heavier box, right? So when he lifts it upward, so that work is positive. When he's lifting it upward means he's applying force towards upward, and the motion is also going upwards. So that means a positive work is there. However, when this guy puts that heavier box on the floor, in that case, the motion is opposite. How? The force is still, he's applying upward, he's lifting it, he's applying force upwards. But after lifting it, he's trying to place that box on the floor. So in that activity, बॉक्स नीचे जा रहा है, फोर्स ऊपर की तरफ लग रही है, बॉक्स इज गोइंग डाउन, द मोशन इज टोटली ऑपोजिट, सो दैट वर्क इज नेगेटिव. And one idea of positive negative works that is not confirmed yet, but it is given in the books that I let you know. In the positive works, the energy used is always less as compared to negative works. Negative works are energy consuming, and the as compared to positive works, energy दोनों में लगेगी, but it has been seen, it has been observed, but there is no law as such right now which relates this. But on the basis of observations, it is written in the books, many books, you can see that energy required during positive work is less as compared to negative works. Negative works में आपकी ज़्यादा energy use होती है. So this is the way you differentiate between positive and negative works. Now next example will let you know how it applies to your biomechanics in the weightlifting, how work done. So you see, so here we have he's trying to lift a weight is of 100 kgs, right? How we calculate work, basically this is just a demonstration. So when the weight is lying on the floor, the actual weights in kg are 100 kg. So when it is lying on the floor, gravitation force is also acting, so that extension due to gravity is 9.8, so total weight becomes 980 newtons. So that amount of force you need to lift that weight, right? So this is your F. Now in this you can see the distance to which it lifts is 1 meter, suppose, right? So you have got two things now. One is your force is 980 newtons, and how much motion it will make of 1 meter. Suppose he did 10 repetition of this. So if he did 10 repetition, that means total distance becomes 10. So what will be the work done? You can calculate very easily. Force into distance. So in the next slide it will become more clear. So you will get the idea how work is calculated, work done is calculated, right? So here you can see work in joules is equal to force into distance. So one repetition, for one repetition it is 1 meter, so work done is 980 joules. जब वो एक बार उसको उठा रहा है, then there is only 1 meter distance, 1 meter displacement, right? On the other hand, अगर वो 10 repetitions करता है, that means कितना वर्क उसने किया, 10 meters का वर्क हो गया, because he is lifting 10 times 1 meter up to 1 meter length. So that means force is same because weight is same. So 980 into 10 becomes 9800 joules if he performs 10 repetitions, right? So in this way you can calculate in biomechanics how work is done. You should know the distance exactly in meters, you should know the weights, and this is how you can calculate work done. Okay, so this is a very crucial parameter when you evaluate athletes, and when you evaluate your movements, how much work you have done, how efficient you are. Okay, now coming to the power. the last concept in today's lecture. So what is power? Power refers to amount of mechanical work performed in a given period of time. मतलब आप 5 seconds में 10 seconds में कितना वर्क करते हैं. What is your ability to perform work in particular time period? That is known as power, and it has direct relation to your abilities of your strength. How what is your power output of an athlete is basically we study in the terms of power. In simple words, it is the rate of work done, and it is calculated by work done divided by time. जितना भी आपने वर्क किया है उसको कितने टाइम में आपने परफॉर्म किया. The one who did it in less time has more power. Suppose 1000 joules of work is being done by two athletes. One is very agile, very well trained, he's a light player. He'll do the same job in 3 seconds, and other one will do in the 6 seconds. So where power will be more, where time will be less. जो faster होगा, who is more agile. So this is the way you can evaluate power strength of an athlete. So it will become more clear in the next slide. Mathematical equation of power, what is it? So mathematically, power is work done over time, change in time. So using this formula you can calculate the power. The power is work done. Work we have already defined. Work is force into distance. So putting that force into distance over change in time, you will get this equation F d over t, delta t. Okay, and if you put the value of d over t, you know what is that? That is speed, velocity, distance over time. So you can also use this equation, modified one, that power is equal to force into velocity. So direct relation आपको velocity और power का पता लगता है. Faster the athlete is, higher the power ability of athlete. Okay, and what is the unit? Watt is the unit of power, and it is defined as power is said to be 1 watt when you do 1 joule of work in 1 second. Simple. I repeat, what is the unit of power? It is watt, and power is said to be 1 watt when you perform a work of 1 joule in 1 second. Simple. Now next equation will give you some demonstration of how power is calculated in biomechanics. So again we will take example of weightlifting. So here the weight is of 50 kgs, and when it is lying you have to multiply with 9.8, that is acceleration due to gravity g. Now the total force required to lift that weight is 490. You can see here clearly. Okay, now suppose again it will move to the distance of 0.75 meter, right? So in this way you can calculate the work. Now it's your exercise to calculate differences in power when the movement takes at 3 seconds versus 2 seconds. You calculate it, and you can calculate here also. It is very simple. If you have calculator, or by manually you can also do. So you have got your force, you have got your distance, and you can then calculate power very easily. Just you have to put time factor. Now what is the application of power in sports? The athlete's ability to exert mechanical power is critical to successful performance. The athlete which is trained, well trained, who is very fast, who is very agile, and also produces large amount of force, will be having more strength, and that will help him to get success in the game. So that's why power is very crucial in sports. And एक आपको लास्ट में प्रॉब्लम दे रहे हैं, who has more power. In this you can see how height of a person will affect your strength or ability of your power abilities. Basically इसमें we have two athletes, one is tall and one is shorter. So both athletes are performing a bench press of 100 kg, 5 repetitions they are doing. Okay, so the taller athlete one has range of motion of 0.65 meters. Range of motion कितना वो motion create करता है उसमें. So that is you are getting the distance, that is 0.65 meter, and the shorter athlete has 0.5 meters. range of motion, and he did in 6 seconds. Okay, so who was more powerful? You have to calculate this, and you can write it here also, and you can WhatsApp in the group also. It's better because काफी viewers आएंगे, they will get to know, and it is very simple. You have to calculate the basically work done, and then you have to divide it by time. Simple, and you will get to know advantage of height. So this is it. Here I have shown you, I think, next slides, but in this way you can try how it actually happens. I have calculated it for you that athlete 1, here is the thing, athlete 1 has work done of 3185, and athlete 2 yani shorter has work done of 2450. Now what is your job? Just to calculate power, and you will see who has more power. Okay, so this is it. Thank you very much for being here, and hope everything is clear, and you can ask any question if you have. So we have covered all three concepts: Newton law of gravitation, elastic biomechanics, and work and power. So only one topic is now remaining in the section A, and in the next lecture, after completing that, we will move to section B in the coming lectures. So thank you very much for being here. If you have any question, please let me know, and please share your experience by comments right here, and do subscribe it so that you can get notification automatically. When you subscribe to this channel, you will automatically get notification whenever I get live or whenever I post some video on this channel. So please share your experience, and thank you very much for being here. So that's it for the today's lecture. Now we'll meet on Wednesday. Thank you. Thank you, Michael. Thank you, Dinesh. If you have any question, you can WhatsApp me also, and you can write here also. I'll reply here also, wherever you want. Okay. Thank you, Nita. Thank you, Sai. And hope it was clear. Everything went well. Sound, slides, transition, everything was clear in the webinar. कैसा रहा आपका experience? So ending up the show now. Okay, thank you very much.